Alright guys, I wanted to cover some basics regarding air tubes and bottles and why things are designed the way that they are. This is a 1.75 inch tube, so in 9 inches of this, I think this tube is about 10 and a half, but in, let's say, the 9 inch center section, you can hold 260 cc's. Just for comparison purposes, let's look at, this is a standard size Crossman 2240 Diana Chaser, Benjamin Discovery. Bunch of guns are in that 22 millimeter or 7/8 diameter, so comparatively, it's huge. So what I used to wonder when I first got into air guns, and especially when I got into building them, I used to think to myself, well, the trend seems to be tanks, but I like the aesthetic of like a long air tube. And then, the Marauder came out not too long after I got back into, pellet guns. And the Marauder used like a 1.375 tube, which at the time was pretty big. And there was one custom builder, and I cannot remember his name. Haven't heard much about him recently, but he used to build these amazing titanium tubes. They were like 2 feet long, 2 inches diameter. He'd pressure test them to like 17,000 psi and post the results of, the failures and stuff like that. I wish I could remember his name. But anyway, so I always thought comparatively, tanks were the better option, and there's a reason that they probably still are. Number one, the price of any quality tube like this is 4130 chromoly. It's expensive. Like a 12-inch section of this would set you back, I don't know, let's say $30. Well, a 380 cc, far bigger, internal volume, a 380 cc tank on Amazon would only set you back about 37, and that's plug and play. That doesn't need end caps, it doesn't need machining. It's pretty much a ready to go drop in unit. So a lot of the manufacturers, as we've seen in the last couple of years, they just automatically default to tanks. AEA, on the other hand, which have become pretty big in the last 4 or 5 years, they actually do use some large tubes. I think, for like the Zeus and stuff, those tubes are at least 1.75. They might be bigger because they're in metric. They might be like, 48 millimeter or something, but they're huge. But the downside to that is weight, and that's what we're going to get into. Like, this weighs more than my 380 cc tank, and I don't even have to weigh them to tell you that. It's far more. And part of that is just the way, hoop stress, or the stress inside trying to burst the cylinder itself, the way it's calculated. It's the wall thickness is always proportionate, or it's measured as in comparison to the overall diameter. So let's say you had a tiny air tube for some reason. You had a miniature pellet gun. You made a tiny PCP that was 4 inches long, and the air tube is, let's say 5/16 of an inch diameter. So the walls would only have to be, because it's proportionate, in order to hold 3,000 psi in our imaginary mini PCP, the wall thickness would only have to be about 20 thousandths, because the internal air has less surface area to act on. And remember, when we talk about, PSI, for example, we're pounds per square inch, so it's directly correlated to the surface area the pressure can act on. So the smaller the tube, thinner the walls. The bigger the tube, thicker the walls. So in this case, when you're going with a 1.5 inch inside diameter, not only is the longitudinal stress enormous, in this case 5,301 pounds are pushing these end caps off at 3,000 psi, but the hoop stress is also enormous. So, when you scale up, like AEA has done with a couple of their new models, including the Zeus, those guns end up weighing 10, 15 pounds in some cases, and the vast majority of that is the air storage. You know, it's not the action or anything. It's definitely not the wood stock. So when you look at the weight of like I can't think of the name of the other ones, not the Terminator models, but there's another model that uses a large air tube. It's like a Challenger Target series or something, but they also use a very large air tube, and the overall weight of the gun is directly reflective of that. Now, what are the upsides to using an actual tube versus a tank? The upsides are huge. For example, my flow through here at the back, while using thick walls for everything, inside there, that's my flow through area, is 1/2 inch. And I could go to 625 if I wanted to, or if I needed to, but I only need about 1/2 inch to push, you know, enough air for the gun I'm making. And now if you picture designs, you know, traditional, think 2240 designs where the valve is physically, you know, inside of a tube, you know, where this is slid into here and bolted into place. I mean, if you think about those designs, the air accessibility to the throat, or what you'd commonly refer to as the plenum volume, you know, if the valve is right here, let's say, the plenum volume is literally the entire tube at full bore. So whatever's in the tube that's pressurized is completely available to that plenum, or is the plenum rather. It's available to that valve throat. So, you know, with a traditional tank design like the M18 threaded, you know, tanks, let's say you got rid of the regulator and you wanted the most direct setup possible, you know, the most you could flow through there with the O-rings and everything, I don't even know if it is 1/2 inch. I'd have to do, you know, I'd have to do some measuring and stuff and do some math to figure out what the elongation stresses would be on the material. I guess if you made the connection out of steel and, you know, everything was ideal and you used low profile or low thickness O-rings, you know, you could get away with a decent flow, but you could never compete with either a valve in tube design or tube off monoblock design where there's virtually no restriction and your plenum flow through is far greater than what's beneath your poppet or your throat diameter. So that's a huge advantage. The other advantage, not in this case, because this is all this is bolted externally as opposed to threaded, but in many cases, you know, it's aesthetically pleasing if you just have that straight tube design, or at least I think it is, and that's up for discussion. But I think the straight tube kind of matching the barrel in, you know, a clean linear fashion looks better than, you know, the kind of bulbous outline of a tank. And there's some tanks now, especially high-end carbon fiber ones, that are getting smaller diameter and they're real slick looking. I don't mind those, but, you know, the bigger the tank, I feel like the more awkward or unbalanced the gun looks. So yeah, there's pros and cons to both, but it's definitely cheaper and quicker for manufacturers to simply use a tank or even double tanks. It would still be cheaper in a lot of cases as opposed to the machining process. You're getting the weight reduction, and 99% of guns don't need the level of flow where you'd need, you know, 1/2 inch, where you'd have or need a 1/2 inch flow rate direct to the valve. You know, this is designed for a 74 caliber, so that's exceptionally rare. But for everything up to 9mm, I mean, if you look at a Benjamin Bulldog, the transfer port is only a 1/4 inch. So if your transfer port is a 1/4 inch, and let's say the throat on that thing is, I don't know, 300 thousandths, you don't need a 1/2 inch hole to feed a 300 thousandths hole. So, but yeah, just a couple interesting observations about how I used to think that maybe the airgun manufacturers were like, you know, going with tanks for some obscure reason. You know, maybe they thought it was a better looking design, or, you know, maybe there was some stress factor in larger diameter tubes where they literally couldn't do it, where, you know, the engineering prevented it. But yeah, none of that was the case. It was, it's just simply cost, weight, and just efficiency. You're also another benefit, another side benefit of a tank is that you're not dealing with seals. You're not dealing with multiple seals. You're dealing with one seal at the end of the tank that connects to the gun. In the M18 or 5/8 threads. You're dealing with one seal. You already have a sealed system. With this design, let's just say the Foster and Gauge were on the monoblock over here. You're still dealing with double the seals. You at least have one more to deal with. And then lastly, I would say, and this is just an assumption, is that with the tanks, you're not insuring the design yourself. Like if I put this out on the market for some reason, and you're insured as a business. Let's say I was, Crossman. So I'm insured as a business. I put this out on the market. My engineers would have to give me some serious assurance that one of these caps isn't going to give way, because if it does, it's likely to be a catastrophic event. Whereas if I buy a tank from, one of the popular makers, let's say I buy the tanks from Ninja, now Ninja's providing the assurance that these tanks are good for whatever pressure testing or yield rating that they claim. So it's less to do in-house. If you're making the air tubes, you're making them in-house. I'm hoping I didn't overlook anything on this, but yeah, I just wanted to give some general perspective on why we've historically always seen, smaller tubes with thinner walls and less volume available, and why we haven't seen 1.75 inch chromoly air tubes. And it's it's necessity, it's weight, and it's hassle. The only reason I'm using this is because I already had the tube on hand, so I figured I might as well put it to use. But anyway, I hope this was interesting or educational. Not too many people watch my long form videos, so most of you are probably airgun nuts anyway. Thanks for watching.